Welcome to section 7.1, Law of Sines. In this section, we have one objective: solve problems involving triangles using the law of sines. So far, we've mainly solved right triangles using basic trigonometric ratios. But when a triangle does not have a right angle, we need a different tool. And this tool is called the law of sines. The law of sines describes a relationship between the angles and the sides of any triangle, not just right triangles. It allows us to solve for unknown sides or angles when enough information is given, even if the triangle is oblique, meaning it has no 90-degree angles. So the law of sines states that the ratio of the sine of an angle to the length of the side opposite that angle is constant in any triangle. So in symbols, it is written as the sine of A over lowercase a, the sine of B over lowercase b, the sine of C over lowercase c, or equivalently their reciprocals. So for any triangle AB, not just right triangles, where lowercase a, b, and c are the side lengths, and uppercase a, b, and c are the angles opposite those sides. Okay. This formula shows the proportion between the length of a side and the sine of its opposite angle. So if you had a triangle, and we'll give each vertex the uppercase letters because they represent B. Sorry, they represent the angles. So A, B, C, and then their opposite side lengths will be the lowercase values. Okay. You will be able to then set up your law of sines formula. So how do we use the law of sines? Well, to use the law of sines when solving triangles that give you two angles and one side. So in some cases, this may be angle, side, angle. So you're given an angle, the side, and then an angle. So between the two angles, you have a side that's given to you, or angle, angle, side. So you have two angles and then a side, or two sides and a non-included angle, where this is side-side angle, but we need to be careful because side-side angle may lead to an ambiguous case with one, two, or no triangles. And we'll look at this case in the next section. Okay, so we use the law of sines when we have these three cases. Here are 4 steps that we could take to solve a triangle using the law of sines. So the first step is to set up a proportion using the known angles and sides. So identifying what are the angles in your triangle, what are the side lengths in your triangle, and then plugging that into the formula for the law of sines. Then step 2, substitute known values into the proportion. Step 3, solve for the unknown side or angle. And then step 4, use the triangle sum theorem. So knowing that all the angles in a triangle equal 180 degrees in order to find your missing angle measures. Okay. All right, so let's do a couple problems together. Okay, here is our first problem. In triangle ABC, angle A is 40 degrees, angle C is 60 degrees, A equals 7 inches, and the length of side B is what we are asked to find. Okay, so let's first draw a triangle to help us visualize this problem. Oops, let me redraw that one. That side. Much better. All right, so we have vertex A, vertex B, vertex C, and then we know angle measure A is 40 degrees, C is 60 degrees, and the side A is 7 inches. Okay, So we don't know side C and we don't know side B, and side B is what we're looking for. We can find the angle measurement of B because A, B, and C must equal 180 degrees. Okay, so let me write that out for you. So that is the triangle sum theorem, that all three angle measurements in a triangle equal 180 degrees. So if I want to find the angle measurement of B, I'll take 180 minus the sum of my two known angles, which is A and C. So plugging in the values of A and C, 40 and 60, when I simplify, I then get 80. So I know the angle measurement of B is 80 degrees. Okay, so now that I know my angle measurement and I have identified the length that I'm trying to find, let's set up our law of sines. So that would be A over the sine of angle A equals B over the sine of angle B, which equals C over the sine of angle C. So my side length for A is 7. Its angle is 40 degrees. I'm trying to find the side length of B, but I know its angle is 80. The side length for C I don't know, but I know the angle is 60. Okay, so we're trying to find B. That's what our problem told us to find. Okay, so when you have set up your law of sines formula and plugged in all of your values, you now want to identify the two ratios that you're going to use to solve for your unknown. You just need to make sure that the two ratios that you choose has only one missing value, so only one variable. You never want to choose two ratios that have two unknowns, okay? Because the goal of setting these ratios equal to each other is to solve for the unknown variable, okay? So we're going to choose the first two, all right? Between these two ratios, there's only one unknown, and that unknown is B. So since we have two ratios, what we can do is we can cross multiply to help us find the value of B. So we have B times the sine of 40 equals 7 times the sine of 80. So if I want to get B by itself, I would divide both sides by the sine of 40. Plugging this into my calculator, making sure that my mode is set to degrees, I will get the value 10.7 inches. And that is the side length of B. All right, let's do the next one. Find the missing parts of triangle ABC if A is 46 degrees, C is 78 degrees, and the length B, side B, is 7.5 centimeters. So let's draw our visual to help us. Set up a vertex. All right, angle measure A is 46. C is 78. And side is 7.5. All right. So in this problem, all right, we are given two angle measures, which means we can find the angle measure of the third angle, B. So B will be equal to 180 degrees minus the sum of the other two angles. So that would be 46 plus 78. So that would be 56 degrees. So let's plug that in. Okay. So now that I have all my angles, because I was given 2, I know now that my missing parts, my other 2 missing parts, are the length A and the length C. Okay, so those are the 2 other missing parts that I need to identify, because I have identified the angle B, right? And that came out to be 56 degrees. So let's set up our sine formula. So we'll have A over the sine of angle A, which is 46, equals B, which is 7.5, over the angle B, which we found to be 56, and C over the angle C, which is 78. Okay, so we are going to choose 2 ratios to help us find an unknown. So we first are going to take these 2 ratios to help us find A. All right. And then we are going to we can either take the ratio for B to help us find C, or we can take the ratio A that we've just found to help us find C. Either one works, but first let's find A. So when we cross multiply, we'll have A times the sine of 56 equals 7.5 times the sine of 46. I want A by itself, so I will divide both sides by the sine of 56. Entering that into my calculator, I roughly get 6.5 centimeters for the value of A. So now I know A equals 6.5. So now I need to find C. So we're going to use the ratio of B and C to help us find C. So when we cross multiply, we'll get C times the sine of 56 equals 7.5 times the sine of 78. So to get C by itself, I'm going to divide both sides by the sine of 56. C then will approximately equal 8.8 centimeters. Alrighty. Okay, example 3. Find x in the figure if A equals 738 feet, B equals 6.3 degrees, and A equals 78.4 degrees. So we've given some values. We have a visual here that's been labeled, but now let's input the values that are given to us. So we know A is 738 feet. We know B is 6.3 degrees, and we know A is 78.4 degrees. Okay, and we're trying to find X. All right, so let's set this up using the law of sines to see if we can find our missing part X. So we have A over sine of A and B over sine of B. So A is 738. The angle A is 78.4. The side B is X and the angle B is 6.3. So we can utilize these 2 ratios to help us find X by cross multiplying. So x times the sine of 78.4 equals 738 times the sine of 6.3. To get x by itself, I'm going to divide both sides by the sine of 78.4. When I substitute this ratio, not substitute, but enter this ratio into my calculator, I will then get 82.7 feet for my value of x. All right. So now we're going to walk through a problem that's similar to the example in your textbook for problem number 4. Okay? Some of the values have changed, but the process is very similar. So let's say a hot air balloon is flying over a dry lake when the wind stops blowing. The balloon comes to a stop at point D, which is 600 feet above the ground, at point C, as shown in figure 7. A Jeep following the balloon runs out of gas at point A. The nearest service station is due north of the Jeep at point B. The bearing of the balloon from the Jeep at A is north 13 degrees east, while the bearing of the balloon from the service station at point B is south 19 degrees east. If the angle of elevation of the balloon from A is 15 degrees, how far will the people in the Jeep have to walk to reach the service station at point B? Okay, so we have our hot air balloon right here at D. It is 600 feet above the ground from point C. Okay. We have a Jeep that ran out of gas and stopped at point A. Okay. The nearest service station is at point B. This is the service station. At point B. Okay. Okay. So the bearing of the balloon from the Jeep is north 13 degrees. So that's identified right here. Okay. That's north 13 degrees right here. While the bearing of the balloon from the service station at B is 19 degrees, which is given me. Okay. If the angle of elevation of the balloon from A is 15 degrees, okay, so the elevation, right, elevation, we have a straight 180-degree line, which is A to C, and the elevation then is 15 degrees, okay? We want to know how far will the people in the Jeep have to walk to reach the service station. So they want to walk this diagonal line right here. So the length of AB. So that is what we are trying to find, the length of AB. That is what our question is asking us, because that's how far they will have to walk. All right. So the first thing that we need to do in order to find this length AB is we need to find the distance between A and C. Okay. The distance between A and C will then allow us to find the angle measurement of C, which will then allow us to use the sine formula to help us find the length of AB. Okay. So the first thing that we're going to look at, and I'm going to try to highlight it here for you so that you can see it, because there's a lot of visuals going on, is we're going to use this triangle right here to help us find the length of AC, right? Which is going to also be the distance from A to C. So we're going to find the length AC. Okay, so if we want to find the length AC, we can use our trig acronym to help us. And our trig acronym is SO, PA, TOA. We have the angle measurement, which is 15 degrees. The opposite side is 600 degrees. We want the adjacent side, X, which is A. So the tan of 15 degrees equals 600 divided by X. So X equals 600 divided by the tan of 15. Substituting that into our calculator, we get an estimate of 2,239 feet. Okay? So that is the distance between A and C. So let's enter that onto our visual here. 2,239. All right. So now that we have that, we now can look at our next triangle. I'm going to highlight that here first. That would be this triangle. All righty. Okay. So in this triangle, we now want to find the angle measurement of C. Okay. Let's see. This whole angle. And we can find the angle of C by using the triangle sum theorem. So the angle measurement of C is going to equal 180 minus the sum of our other two angles. And in this case, it's going to be the 13 degrees. Oops, I didn't mean to remove our highlighted portion here. There we go. It's going to be the 13 degrees and the 19 degrees. So when we simplify that, we will get 148 degrees. Okay. So then our last step is then to find the length of AB. Okay, so that's the distance that the people are going to have to walk from the Jeep to the service station. Okay. And just to help us out a bit, let's resketch this triangle. It's a little upside down, but that's okay. We're just going to flip it. This is A, B, C. We know C is 148. We know A is 13. We know B is 19. We know the side C is what we're trying to look for because that's AB. Side B is 2,239. All right. And side A isn't given to us, but it's not something that we are looking for. So since we know we don't have the side A, we're going to be using the ratios for B and C to help us find X. So side B is 2,239 divided by the angle, sine of the angle B, which is 19. And then our side for lowercase c is X. and the angle of C is 148. Okay, so when we cross multiply, we'll have sine 19 times x equals 2,239 times the sine of 148. So x equals 2,239 sine 48 divided by the sine 19. So x is approximately 3,644 feet, which means the distance that the people in the Jeep have to walk to reach the service station at point B from A is 3,644 feet. Alrighty. Well, that concludes section 7.1.